Welcome back to the Deep Dive. Our mission today is to give you, well, the ultimate shortcut to being well-informed about one of the most practical and fascinating fields out there, user experience design.
That's right. Specifically, we're dissecting the psychological blueprint that determines why some digital products just feel effortless, and why others feel like constant friction.
If you're building software or designing interfaces, maybe managing products, this deep dive is, I think, absolutely essential. We're trying to move beyond those subjective arguments like, I think this button looks better here.
Exactly. And instead, we're grounding design decisions in empirically supported human behavior.
Our main source material is built around this amazing framework laid out by Jon Yablonski in his book, Laws of UX. And the story behind the book is just incredible. Yablonski, he needed to justify his design decisions to stakeholders, but he often didn't have the resources for, big quantitative A/B tests or these long user studies.
So he was kind of in a bind. He couldn't rely on just a gut feeling or these tiny sample sizes. He needed undeniable proof. And that search led him straight into behavioral and cognitive psychology, a field he called a treasure trove of knowledge that explains why we do what we do online.
And we're extracting that foundation today. We want to understand the patterns of human perception, decision-making, and memory that, that really underpin these intuitive, human-centered products.
We are essentially giving you the cheat sheet to the operating system of the human mind, but applied directly to interaction design.
I like that. Our whole objective is to connect these, timeless psychological laws to the modern interfaces you use every day, helping you recognize the difference between a random design choice and one that's actually rooted in fundamental human nature.
Exactly.
Okay, so let's unpack this by looking at where this relationship between psychology and design even began, because this is not a 21st century thing, is it?
Not at all, no.
Yeah.
To really get the root of modern UX, you have to go all the way back to the early 20th century with something called Gestalt psychology.
Right. This movement, it was championed by pioneers like Max Wertheimer, Kurt Kafka, and Wolfgang Kohler, and it just fundamentally changed how we view perception.
And the core idea of Gestalt is often summarized as the whole is greater than the sum of its parts.
Precisely. They focused on this idea that when we perceive something, we don't process these little isolated elements. Our brains just automatically organize them into meaningful wholes, into patterns and structures. We're pattern-seeking machines.
So this is where we get principles like figure ground.
Figure ground, how we distinguish an object from its background. Similarity, where we group similar-looking items together. And proximity, the idea that we assume things that are close together must be related.
So every time a designer uses white space to group related stuff on a dashboard, or uses consistent colors for all the main buttons, they are actually applying these 100-year-old Gestalt principles.
They absolutely are.
Yeah.
But these principles really became, institutionalized during a period of massive crisis, World War II. And that's what spurred human factors engineering. This is where the cost of a badly designed interface became, quite literally, life and death. The U.S. Air Force was having hundreds of crashes, and they were often just blamed on pilot error.
Yes, and that's a key phrase. In just one 22-month period, over 450 crashes were initially labeled pilot error. So psychologists like Paul Fitts and Alphonse Trapanis were brought in to investigate, and they concluded that the pilots weren't incompetent.
It was the cockpit.
The cockpit controls were designed completely against human intuition and capability, especially when you're under incredible stress.
I remember reading they couldn't tell the difference between the landing gear and the flap controls.
Correct. The controls were often identical knobs just placed side by side. So Trapanis is famous for introducing what he called shape coding.
Making them recognizable by touch alone.
Exactly. So the pilot didn't have to look down or even think in a crisis. And this was a radical shift in thinking. Instead of training the human to adapt to the machine, they adapted the machine to the human's limitations.
And that concept, designing the system to account for our human quirks, that is the fundamental basis of what we now call human-centered design.
And that idea, it evolved even further with the rise of computing in the Cold War era, leading to human-computer interaction, or HCI. Early computers were incredibly rigid. They were these systems that users had to learn the language of.
But then you have these innovation hubs like Xerox PRX, and they just changed everything. They pioneered the concepts we completely take for granted today.
Oh, completely. Xerox PR gave us the laser printer, Ethernet networking, and, critically, the graphical user interface, the GUI. They wanted to make computers personal and accessible to everyone.
I recall this source mentioning a really pivotal moment, this 1983 book, The Psychology of Human-Computer Interaction. Why was that so important?
Well, that book explicitly married cognitive psychology, how we think and process information, with computer science. It helped solidify the whole idea of the metaphorical desktop.
The idea that a computer screen could mimic organizing physical documents on a real desk.
Yes, and that concept allowed users to leverage their pre-existing real-world mental models to interact with these new digital systems.
Which brings us right up to the modern concept of user experience design. And the famous name here is Donald Norman.
Donald Norman, a cognitive scientist, is widely credited with coining that term user experience. And his background, interestingly enough, included investigating the 1979 Three Mile Island nuclear disaster, where poor control room design was a major contributing factor. He realized that design had to prioritize a positive and satisfying experience across the entirety of a user's interaction with a product.
And we can't forget Jane Fulton Surrey at IDEO, who championed ethnographic research, actually studying users in their natural environment to really embed psychology into the design process. That led directly to the widespread adoption of human-centered design.
The takeaway from all this history is really clear. Every single successful leap in interface design, from the cockpit to the iPhone, has come from understanding the user's cognitive and physical limits, and then shaping the technology to fit those limitations, not the other way around.
Okay, let's dive into the laws themselves, starting with the foundation of expectation. Jacob's Law. It sounds so simple, but it underpins pretty much every navigation decision we make online.
It really does. Jakob Nielsen, the usability expert, formulated this law, and it states that users prefer your site to work the same way as all the other sites they already know. Because the vast majority of a user's time is spent elsewhere, they bring those external patterns into your product.
So if you conform to those patterns, you get this massive boost in usability right out of the gate. But if you deviate,
You create a roadblock. And the mechanism for this is something called mental models. A mental model is our internal representation of how we expect a system to work. You can think of it like a schema or a cognitive map.
so designers who match their product to the user's existing mental model allow for this immediate knowledge transfer. The user doesn't have to learn, they just do.
Precisely.
What are some of the most fundamental examples of this? Leveraging models from the physical world.
Well, just look at form controls. Why do we instantly understand a toggle switch on a screen?
Because it's based on a physical light switch.
Exactly. It's based on the physical affordance of a light switch. Radio buttons, check boxes, they all stem from physical control panels. We know how they work because their digital versions preserve that conceptual model from the physical world.
And this extends to larger patterns too. I mean, every e-commerce site, whether it's Amazon or Etsy or some small boutique, they all adhere to a standard checkout flow, right? Search bar at the top, shopping cart icon, then this structured sequence of shipping, payment, and confirmation.
Absolutely. By conforming to that convention, the user focuses all their cognitive energy on the purchasing decision itself, not on trying to figure out how to get to the next step. If you hide the shopping cart or rename the checkout button to something clever like acquire goods, you are forcing the user to stop and learn your unique vocabulary.
And that's where things can go spectacularly wrong, leading to massive user backlash. The prime example the source cites is the 2018 Snapchat redesign.
Oh, that redesign was a textbook failure of mental model mismatch. They completely collapsed the social messaging feed with the professional content feed, which fundamentally altered how users expected to navigate and consume content. It was a complete format shock.
And instead of a gradual adjustment, it was this immediate, jarring overhaul that just flew in the face of established patterns used by their competitors, like Instagram. And the result was mass disapproval and a huge migration of users.
They forced adoption without giving the user any kind of bridge between the old model and the new one.
Now, you can contrast that with a successful transition like Google's 2017 YouTube redesign.
Right. They allowed desktop users to preview the new Material Design UI. You could opt in, use it for a while, and, crucially, you could revert back to the old version. They used a controlled, voluntary exposure to mitigate that inherent friction of changing a deeply ingrained mental model.
Even the most cutting-edge tech has to respect Jacob's Law. If you look at Apple's Vision Pro, which is introducing this whole new world of spatial computing, it still uses familiar elements like windows, tabs, and sidebars.
It's building on the established model of a graphical interface, rather than requiring users to learn a completely alien form of interaction from scratch.
So that leads to the necessary challenge here, though. If we always follow convention, how do we ever innovate, Doesn't Jacob's law just promote sameness?
That's a really fair question. But innovation should focus on making the task easier, not on making the interface unique just for the sake of novelty.
I see.
Precisely. If every application was totally unique, our productivity would just grind to a halt because every single task would require exploration and experimentation. The idea is to use convention strategically in those high-stakes areas: navigation, search, identity, where consistency maximizes usability. You save your innovation for the core task or feature where you can genuinely improve the user's life.
So if you depart from convention, you have to have really rigorous testing to prove that the novelty is measurably better for the user, not just different.
Exactly.
Okay, moving now from expectation to the mechanics of movement, we hit Fitts' law. This is one of the oldest and most useful laws for interaction designers.
Right. Paul Fitts defined this mathematically way back in 1954, and the law states that the time required to acquire a target is a function of the distance to and the size of that target.
In plain language, bigger targets placed closer to where the user currently is are faster to select.
It's that simple. And this principle is so essential because digital interaction, whether you're clicking a mouse or tapping with your finger, is fundamentally about movement and precision.
It generates 3 clear derived guidelines for designing interactive elements. Let's start with size.
Okay, so targets must be large enough to accommodate the natural imprecision of the human hand or the cursor movement.
And this is where we get into specific metrics, often based on physiological research, like that MIT Touch Lab study on fingertip size.
That's right. That research found the average adult fingertip is between 16 and 20 millimeters. So, industry standards set these explicit minimums. Apple recommends 44 by 44 points for touch interfaces. Google Material Design suggests 48 by 48 density-independent pixels, or DP.
Okay, hold on. For someone less familiar with that jargon, what exactly is a DP, and why do we use it instead of just, say, millimeters?
That's a great question. A density-independent pixel, or DP, is a unit of measurement that's used mostly in Android development. It's used to make sure that an interface element appears the same size visually, regardless of the screen density, how many actual pixels are packed into a physical inch.
So it's crucial for consistency across all the different phones and tablets.
Exactly. If we just use raw pixels, a button would look tiny on a high-resolution screen, but massive on a low-resolution one. So 48 by 48 DP ensures a comfortable, predictable size across all those devices.
Got it. And even the accessibility guidelines, the WCAG Act, they have a minimum threshold, right?
They do. The Web Content Accessibility Guidelines set a minimum of 44 by 44 CSS pixels, and that's to ensure usability for users with motor control issues or low vision. And these are hard minimums. Often, bigger is better.
The second guideline is spacing. Even if your targets are large enough, if they're crammed together, errors are just going to increase.
We call that a selection error, or false activation. This is why Google recommends touch targets be separated by at least 8 dp. That small buffer zone accounts for the physical size and imprecision of the finger, ensuring that an adjacent element isn't accidentally activated.
And the third, which is increasingly important on these massive mobile screens, is positioning. It's not just about size and spacing, it's about reachability within the natural constraints of your hand.
There's research from usability experts like Stephen Huber that shows a really strong pattern. Users primarily interact with the center of the screen, and that's where their accuracy is highest. The corners, especially the top corners, are hard-to-reach zones, particularly when you're using your phone one-handed.
And that challenge became so acute when smartphones got larger, which led to solutions like Apple's reachability feature.
That was a direct acknowledgement of Fitts' law in the context of large screens. By allowing users to quickly pull the entire screen content down with a gesture, they effectively brought those hard-to-reach top targets closer to the thumb zone, which minimizes the distance and effort required to acquire the target.
We see Fitts' law applied in form design, too. Like when you click the text label next to a tiny radio button, and the interaction still registers.
Yes, that's a really clever application. By coding the entire text label area as part of the actionable target, designers effectively expand the target width without visibly cluttering the interface. It just increases forgiveness and reduces the need for pixel-perfect precision.
And the placement of submission buttons, putting them close to the last active field, that's just minimizing travel distance.
Exactly. And let's not forget infinite targets. The edges of a computer screen or a mobile device, they act like walls. If you move your cursor or your finger to the edge, you can't overshoot the target.
which makes things positioned along the screen edge, like the macOS application menu or the Windows taskbar, inherently easier and faster to acquire than targets in the middle of the screen.
It's a fascinating insight. You're turning a physical constraint, the screen boundary, into a massive usability benefit.
Now we transition from physical movement to cognitive processing. We're moving into the laws that define the limits of the human mind, starting with the famous, but often misquoted, Miller's Law.
This is maybe the most famous psychological principle in design. It comes from George Miller's 1956 paper, The Magical Number 7 plus or minus 2. And the original assertion was that the average person can retain about 7 plus or minus 2 items or chunks in their short-term memory.
And the fatal misinterpretation in design circles is always, our navigation menu can only have 7 items.
That is the myth we must dispel. Navigation menus, toolbars, filters, they're all visible. You don't need to memorize them. Miller's work was strictly about the capacity of short-term memory, which is like the mental scratch pad we use to process information right now. And in fact, later research suggests the true capacity is probably closer to 4 items, especially when the information gets complex.
So if it's not a rule for how many links to have, what is the core actionable concept for designers?
The core concept is managing and reducing cognitive load. This is the total amount of mental resources you need to understand and interact with an interface. If you run out of these mental slots, it leads to frustration, errors, and just abandoning the task.
We should probably break down cognitive load, because it isn't just one thing, is it? There are different types that designers have to manipulate.
That's a vital point. We classify it into 3 types. There's intrinsic load, which is the inherent difficulty of the task itself, like learning a new language. Then there's extraneous load, which is the effort you waste trying to understand a poorly designed interface. Bad labels, confusing navigation.
And the third one.
And then there's germane load, which is the mental work that directly contributes to learning and building those mental models, which is actually desirable.
So a UX designer's primary job is to minimize that extraneous load, the unnecessary friction created by bad design, so the user can focus all their resources on the intrinsic load of the actual task they're trying to do.
Exactly. And the technique that Miller focused on to manage all this is chunking. Our short-term memory limit is based on the number of chunks we can hold, not necessarily the size of the information within those chunks.
Right.
So by grouping related information into familiar, meaningful units, we reduce the total load.
The phone number example is the classic one. 555-123-4567 is really hard to recall, but 555-123-4567 is 2 or 3 manageable chunks.
In digital design, look at how we handle dense information. If you present a user with a wall of text, no hierarchy, lines that are too long, you just overwhelm their working memory. You're forcing them to hold too much disorganized information in their mind all at once.
So the solution is chunking using visual techniques.
Yes. Add descriptive headings, use white space to separate logical groups, shorten the line lengths for readability, use bullet points. These techniques transform an intimidating high-load document into something scannable and low-load. You see this on sites like Nike.com, where product details, images, sizing, pricing are all grouped by proximity, making it efficient to process.
Okay, so Miller's Law helps us organize information, but Hick's Law tells us what happens when we force the user to interact with all that organization. This is all about the cost of choice.
William Hick and Ray Hyman established this law in 1952. The time it takes to make a decision increases logarithmically with the number and complexity of choices available. More options, more deliberation, slower response time.
This insight connects directly to the paradox of choice, which was popularized by the psychologist Barry Schwartz. Why does increasing choice cause so much psychological stress?
Well, Schwartz argued that beyond a certain point, more options actually degrade the user experience because of 2 primary emotional costs: choice overload and anticipated regret.
Choice overload paralyzes the user.
Right, they can't decide what to pick. But even worse, when they finally do choose, they worry about all the options they missed. That's the regret. Or they blame themselves if the choice turns out to be suboptimal.
The famous Jam study, 24 flavors versus 6 flavors. The customers who saw only 6 were 10 times more likely to actually buy some. They reduced the cognitive burden and the risk of regret.
Correct. The fewer choices, the faster the decision, and the higher the satisfaction, because there's just less opportunity for that post-choice regret. So the design application is clear. Minimize choices when speed and conversion are critical.
This is why product interfaces should use progressive disclosure. Instead of overwhelming the user with every possible feature up front, You reveal complexity only as the user indicates they need it.
Google search is the canonical example of this. The landing page is just one input box. The initial task is radically simplified. Only after you search are all the complex filtering options, images, shopping, news revealed. It adheres to Hick's law perfectly.
And it's why onboarding flows, like for complex tools like Notion, they often use checklists. They break down the overwhelming task of learning the whole system into these small, manageable, sequential choices.
We also see solutions for choice paralysis on streaming platforms. Netflix knows that if you spend 18 minutes just browsing, that's a failure. So by highlighting categories like trending now or top picks, they're using social proof and contextual cues to shrink the decision space, giving you fewer choices you actually have to evaluate.
But what's the counterpoint here? We have to avoid oversimplifying to the point where the user can't understand the options at all.
Absolutely. The biggest trap is ambiguous iconography. Designers, in an effort to simplify and save screen real estate, often remove text labels. But if an icon isn't globally instantly recognizable, and most are not, you force the user to stop, recall, or guess its function. That massively increases extraneous cognitive load.
So while Hick's law demands fewer choices, they must be choices with crystal clear meaning.
Yes. That's why so many successful platforms, like X or many navigation apps, they retain both the icon and the text label. The icon is fast for recognition, the text is fast for confirmation. Combining them just reduces the risk of ambiguity and the decision friction that follows.
Let's shift gears to how design manages errors and shapes our memory of the experience, starting with a principle that was actually born in network engineering, Postal's law, the robustness principle.
Jon Postal introduced this back in the 1980s for the TCP/IP network protocol, and the mandate was, be conservative in what you do, be liberal in what you accept from others.
In network terms, that means the system should send out perfectly formatted data, that's the conservative output, but be extremely forgiving when it's receiving poorly formatted data from another machine, the liberal input.
In UX, this means the system must design for the inconsistency, the distractibility, and the inherent error proneness of the human user. The design should anticipate virtually any user input or capability while providing reliable, accessible output.
Let's focus on that liberal input side first. How do we design forgiving forms?
By being conservative about what you ask for, only the absolutely necessary information, but liberal in the format you accept. Don't enforce these arbitrary, restrictive formatting rules for phone numbers or addresses or hyphenated names. The system should absorb the complexity of parsing the input, not push that formatting complexity onto the user.
And if an error does happen, the feedback needs to be super contextual and, I guess, non-judgmental.
Exactly. Telling a user their credit card number is wrong is conservative feedback. Telling them the CVV is missing or the expiration date is expired is liberal, helpful input that guides them to the solution. Postal's law demands fault tolerance in that human-machine handshake.
We also see Postal's law in the foundations of how we build the modern web, like with responsive web design.
Ethan Marcotte's 2010 introduction of RWD really embraced this concept of fluidity. The design has to conservatively present content that adapts to any screen size, from a watch to a huge desktop monitor, liberally accepting any viewing context the user throws at it.
And the similar concept of progressive enhancement.
That ensures that the core functionality and content is accessible to all users first, regardless of their browser, their connection speed, or JavaScript support. Only then do you start layering on sophisticated styling or interactive elements. It's a design strategy that builds resilience into the product from the ground up.
The source also mentions the importance of handling internationalization. That seems like a key area where systems have to be resilient.
Oh, absolutely. Just think about text expansion. English tends to be relatively compact, but when you translate it into languages like Italian or German, that text can expand by up to 300%. If your layout is rigid, that expansion will just break the design. Postal's law forces us to design layouts that are liberally tolerant of massive content shifts.
It's all about making that communication channel as resilient as possible. And if we succeed in making the flow resilient and error tolerant, we start to influence memory, thanks to the peak-end rule.
This law, from the Nobel laureate Daniel Kahneman and his colleagues, states that we don't remember the average of an experience. We remember an experience based almost entirely on just two moments. The peak, the most emotionally intense point, whether positive or negative, and the end.
The cold water experiment illustrates this perfectly, doesn't it?
It really does. Participants had one hand immersed in painfully cold water for 60 seconds. Then they had a second trial. 60 seconds of that same cold water, followed by 30 more seconds where the water was only slightly warmer, but still uncomfortable.
And when they were asked which trial they would repeat, many chose the longer one.
They chose the longer one because the slightly less painful ending made the overall memory of the experience less negative.
So this means designers have to conduct user journey mapping, not just to track tasks, but to actually map the user's emotional landscape and intentionally design for those critical moments.
On the positive side, we design positive peaks. Think of Duolingo. They use gamified features, brand humor, and these visual rewards like reaching a legendary level or celebrating a long streak to create powerful, personalized moments of achievement that reinforce a positive memory.
And the ultimate positive peak: Spotify Wrapped.
It's just a masterful application. It creates this intensely personal, reflective, and shareable celebratory moment at the end of the year. It uses the platform's data to create a high-value, high-emotion peak that really defines the user's entire relationship with the product for that year.
Conversely, we have to mitigate the negative peaks. Wait times are unavoidable, but the perception matters more than the reality.
This is where Uber really succeeded in reducing cancellation rates. They mitigated the anxiety of waiting through 3 psychological techniques: idleness aversion, showing the car moving on the map, giving you something to watch;
Right?
operational transparency, explaining how the times are calculated; and the goal gradient effect, clearly mapping the progress toward arrival. They reduced the perceived pain of that negative moment.
We also need to remember negativity bias. Negative experiences stick in our memory far more vividly than positive ones.
If you hit a catastrophic error, that one moment defines the entire experience. So designers have to prioritize real-time, helpful validation like MailChimp's instant password complexity check, so the user never hits the wall of clicking submit only to be told the whole form failed.
Or, if the error is unavoidable, you can inject some personality or humor, like a clever 404 page, to soften the intensity of that negative spike. Now we explore how initial impressions and attention guide the user, starting with the aesthetic usability effect. This law suggests that beauty can actually influence our perception of performance.
This idea originated with a 1995 study by Kurosu and Kashimura, which demonstrated that users perceived aesthetically pleasing ATM interfaces as having higher usability, even when the underlying functionality was identical to the less attractive alternatives.
That initial, immediate judgment is just profoundly influential. And this ties directly back to Kahneman's work on cognitive processing.
Right.
System 1 versus System 2 thinking.
Yes. System 1 is our fast, automatic, impulsive thinking. It's what forms first impressions within milliseconds, relying heavily on visceral cues like visual appeal. System 2 is the slow, deliberate, analytical, and effortful thinking that comes later when we try to evaluate the actual functionality.
So the brain processes beauty quickly and instinctively with System 1, and that positive emotional response then biases the later, slower evaluation from System 2.
Exactly. If the visual design is pleasing, users are more likely to ascribe qualities like efficiency and ease of use to the product, regardless of whether it actually possesses them. This is why the functional minimalism pioneered by Dieter Ramsay Braun, designing these elegant, usable products like the SK4 record player, was so powerful.
And its legacy in Apple products is just so obvious. The refinement of the aesthetics contributed directly to the perception that the iPhone was easier to use than its competitors, often masking minor usability flaws.
Which brings us to a major caveat in research. The aesthetic usability effect can actively mask usability issues.
Meaning, if I run a user test on a really beautiful product, the participants might be more forgiving of errors.
Precisely. Studies, like those by Sonderegger and Sauer on mobile prototypes, showed that users who found a prototype attractive rated its usability higher and reported fewer problems. So designers have to be vigilant. Watch what users do, their actions, their confusion, not just what they say.
Moving on to managing attention, we turn to the von Restorff effect, which is all about making certain elements pop.
Also known as the distinctiveness principle. When you have multiple similar objects present, the one that differs significantly from the rest is the one that's most likely to be remembered and noticed. This allows designers to strategically guide the user's selective attention.
Because if everything is shouting for attention, the user focuses on nothing. You need strategic contrast.
Absolutely. The most critical application is in actions and hierarchy. Look at pricing tables. Notion emphasizes their plus option using a distinct color, maybe a larger scale, and a little badge saying most popular. That element breaks the pattern of the other similar options.
Or in a confirmation model, where the most important choice is usually isolated.
Yes. You use a distinct color and weight for the primary action button, like confirm, and you subdue the secondary action, like cancel. And if the action is disruptive, you use a strong visual contrast, a red color, maybe a warning icon, to ensure the user doesn't accidentally select it.
Now, a note on restraint is critical here. If you use this principle everywhere, it just loses its power, right?
That's the danger of dilution. If every element is designed to pop, the user's eye quickly adapts, leading to what we call banner blindness, where they subconsciously ignore areas that use excessive contrast or motion because they perceive them as advertisements or just distractions.
And we also need to address accessibility when using color for contrast.
Crucial point. We can never rely exclusively on color to communicate meaning or contrast because of users with color vision deficiency. WCAG mandates a minimum contrast ratio of 4.5.1 for standard text. But designers should also use secondary cues like strokes, patterns, size, and especially text labels alongside color.
And a relatively modern consideration, motion contrast.
Right. Excessive or sudden motion isn't just distracting. It can pose a physical risk. Users with vestibular disorders like benign paroxysmal positional vertigo or BPPV, they can experience severe symptoms like dizziness or nausea that are triggered by overly aggressive or unnecessary animation. Restraint is an accessibility requirement.
Let's now jump to a law about system performance and speed, which is just so vital for modern UX, the Doherty threshold.
This is a critical one, established by Walter Doherty and Andy Thadani at IBM back in 1982. The law states that productivity soars when a computer and its users interact at a pace that ensures neither has to wait on the other, specifically under 400 milliseconds.
So 400 milliseconds is the cognitive sweet spot. Why is that specific number so important?
Because anything slower than 400 milliseconds breaks the user's sense of flow and immediate interaction. If the response is under 100 milliseconds, it feels instantaneous. If it's between 100 and 400, the response is perceived as immediate and keeps the user engaged. Once you cross that 1 second mark, the user starts thinking about the computer process, not their task, which leads to mental context switching, distraction, and frustration.
Given the complexities of the internet and processing huge amounts of data, sometimes going faster than 400 meters is just impossible. So how do designers work around that limitation using psychology?
We use techniques to improve perceived performance. Since we can't always change the actual processing time, we change the user's perception of that time.
And what are the best methods for this illusion of speed?
Skeleton screens are excellent. Instead of a blank white page, which gives the impression of failure or slowness, interfaces display these gray blocks or placeholder shapes instantly while the actual content loads in the background. Instagram and Facebook use this heavily. It reduces the impression of waiting and maintains a sense of momentum.
Or the blur-up technique for images.
That's where you load a very small, highly compressed, blurred version of the image instantly, and then you fade in the high-resolution version once it's loaded. This reduces the visual shock of a sudden content jump and makes the wait time feel productive.
And visual feedback, like a progress bar, even if it's not perfectly accurate.
Progress bars and spinners are essential because they provide certainty. Uncertainty breeds anxiety. By showing some form of visible progress, you convert an unknown wait into a bounded, tolerable process.
The most advanced technique, though, is optimistic UI.
Right. Optimistic UI involves displaying the success state before the system has even confirmed the action. For instance, when you tap like on Instagram, the heart lights up instantly, even though the data hasn't been written to the server yet. The system just assumes success. If the transaction fails, which is rare, only then does it display an error. This maximizes perceived speed for frequent, low-risk actions.
So if the system can't meet the Doherty threshold in reality, it uses these psychological tricks to meet it in the user's mind.
Exactly, but it's worth noting the counterintuitive side. Sometimes, response times can be too fast, and that can lead to mistrust. If security scan finishes instantly, the user might doubt that the check was thorough. Purposefully adding a small delay can sometimes increase the perceived value and trust, a moment of intentional friction, like Google's privacy checkup showing a momentary scan animation.
That's a perfect segue into our last law in this section, which is all about who takes on the complexity. Tesler's law, or the law of conservation of complexity.
Larry Tesler, a computer scientist who worked at Xerox PIOC and Apple, established this law in the 1980s. And the core idea is that for any system, there is a certain amount of inherent complexity that cannot be eliminated. It has to be assumed by either the system or the user.
And Tesler's argument was fundamentally an ethical one. The system should always assume that burden.
His reasoning was very clear. He calculated the cumulative cost of friction. If an engineer designs a system that saves them 10 minutes of development time, but costs a million users 1 minute each day dealing with that complexity, the organization is just penalizing the user for the convenience of the developer.
So the designer's job is complexity abstraction.
Right. Think about the complexity inherent in sending an email: authentication, routing, formatting. The system abstracts all of this by pre-populating your sender info and suggesting recipients. Gmail's Smart Compose takes this even further, using AI to abstract the complexity of typing common phrases.
E-commerce checkout is the classic complex process that's been simplified.
It requires inputting 4 or 5 repetitive pieces of information. Services like Apple Pay or PayPal abstract this complexity into a single biometric step. They shoulder the burden of securely managing and exchanging all that data, making the user experience virtually frictionless.
And for a physical system that shoulders massive complexity for a seemingly simple user experience, you just have to look at Amazon Go stores.
The user walks in, grabs items, and walks out without ever checking out. The perceived complexity for the user is 0, but the system is absorbing staggering complexity using computer vision, AI, and sensor fusion to track every single item. They are dedicating extreme technological resources to uphold Tesla's law.
And the future of this is something called intent-based interaction.
Yes, we're seeing platforms use natural language processing to democratize access to sophisticated features. Tools like Mixpanel's Spark feature allow users to perform complex data analysis just by asking questions in plain English. The user doesn't need to learn SQL or complex query structures. The system abstracts that computational complexity entirely.
The key consideration for designers here is the paradox of the active user.
Right. Users are task-focused. They are active, not passive. They will not read the manual. They will start using the software immediately to achieve their goal. This means the system can't rely on upfront education. It has to anticipate the user's immediate actions and provide guidance, tooltips, and contextual help in the moment of use. Tesla's law demands the system be designed to teach itself rather than expecting the user to dedicate time to learning its eccentricities.
We have covered the fundamental human blueprint, but now we get to where this knowledge becomes truly profound and, well, potentially dangerous.
Yeah.
We need to discuss application and critically responsibility.
Yes. We're no longer just talking about making a button easy to press. We are talking about manipulating behavior. So first, designers must institutionalize these laws. Making them visible in the workspace posters, internal show-and-tell sessions builds a shared objective vocabulary for design arguments.
And translating the laws into actionable design principles for the team.
Precisely. A design principle acts as a North Star. For instance, if you define a principle as forgiveness over restriction, you connect that explicitly to Postal's law. The actionable rule for the team then becomes: always allow flexible input formatting and provide non-judgmental, real-time error feedback.
Now, let's address the elephant in the room. With power comes responsibility. This is about the ethical imperative when we apply this human blueprint.
We have to start with the foundational work of B.F. Skinner in operant conditioning. Skinner demonstrated that behavior can be modified through positive or negative reinforcement rewarding desired actions or punishing undesired ones.
But his key discovery, which is exploited by modern platforms, was the power of unpredictable, variable reinforcement.
If a reward is predictable, the behavior quickly becomes robotic. But if the reward is unpredictable, sometimes you get a huge reward, sometimes you get nothing, the organism becomes obsessed with checking for the reward. This creates the most persistent, impulsive, and hard-to-break behavior patterns.
This is the mechanism that powers the modern Skinner box. Slot machines use variable reinforcement, and so do digital platforms.
Think about the pull-to-refresh action on apps like Instagram or X. You pull the lever, and sometimes you get a high-value reward, a crucial message, a viral post, and sometimes you get stale content. That unpredictability drives repeated checking behavior, keeping users locked in an engagement loop that research shows can lead people to check their phones thousands of times a day.
And designers often apply other psychological techniques to maximize time on site by removing friction entirely.
Infinite scrolling and autoplay videos are classic examples. By removing the friction of having to actively click next page or load more, the system prevents the user from making a conscious decision to stop. It encourages passive consumption to maximize ad revenue opportunities.
The power of defaults is also incredibly influential because most users never change them.
This is a silent form of manipulation. If a company defaults its privacy settings to public rather than friends only, the vast majority of users will remain exposed, even if that contradicts their preference. This is where corporate goals, like maximizing data exposure, collide with human goals, like privacy.
And the worst application of all these laws are dark patterns. These are deceptive techniques designed to trick or coerce users into making decisions that benefit the company but harm the user.
We see several types. The Roach Motel, where it's easy to get into a subscription but nearly impossible to find the cancellation path. Or the forced action pattern, where the system provides no real alternative but to proceed with a negative action, like Instagram forcing you to grant access to your entire contacts list to use a core feature.
This brings us to the ethical imperative. Corporate KPIs, time on site, ad views, often stand in direct opposition to human goals, completing a task efficiently or maintaining your digital well-being.
We have to confront the unintended consequences. Features like Facebook's like button, designed for positive affirmation, have been linked by research to negative outcomes like increased depression and loneliness in young adults, all due to social comparison and anxiety. The fact that the intent was positive doesn't negate the resulting psychological harm.
So if we accept this responsibility, what's the counter solution? How do designers intentionally apply these laws for the user's well-being?
The first step is to think beyond the happy path. Designers naturally focus on the ideal, frictionless scenario. We have to prioritize edge cases, non-ideal scenarios, and vulnerable populations first. Design for the moment the user is making a mistake, or when they feel anxious or confused.
And the most powerful tool we have is the one we've spent this entire deep dive trying to eliminate: friction.
We have been conditioned to believe that frictionless equals good UX, but that's only true if the goal is rapid conversion or engagement. Friction can and should be used as a feature to promote positive, reflective, or secure behavior.
What are some concrete examples of using friction as a feature?
Using a deliberate secondary confirmation step before a destructive action like deleting an account prevents errors. That's Postal's law. Adding a brief, required, reflective moment before sharing emotionally charged content promotes moderation and critical thought. Or using a security friction point-like two-factor authentication to protect the user's data, even if it adds milliseconds to the login time. The goal isn't to make technology slower, but to make it intentional. We use psychology to remove the extraneous cognitive load and replace it with germane cognitive load, the effort that leads to genuine understanding, better security, or greater personal well-being.
This has been a transformative deep dive. We've gone from 1950s fighter jet cockpits all the way to modern social media feeds, showing that psychology is really the engine that drives design.
We established the historical psychological foundations in Gestalt and human factors. We learned the non-negotiable importance of familiarity, thanks to Jacob's law, and how movement is optimized by Fitts' law, using specific metrics derived from human physiology.
We detailed how to manage working memory with Miller's law, focusing on chunking and reducing that extraneous cognitive load, and then how to combat regret and paralysis by limiting choice using Hick's law.
And we covered the importance of resilience through Postal's law, making sure the system is forgiving of user input, and the profound power of memory management, where the peak end rule defines the entire user experience.
We explored how aesthetics bias our perception of usability, thanks to the aesthetic usability effect and the speed of System 1 thinking, and how the Doherty threshold dictates that perceived speed under 400 milliseconds is paramount for productivity.
Finally, we understood that complexity cannot be eliminated, only shifted, requiring designers to shoulder that burden. That's Tesla's law. And that the application of all these laws holds a profound ethical responsibility.
So here is the challenge, a final provocative thought to take with you. We have seen that designers can use variable reinforcement and the elimination of friction to create incredibly addictive engagement loops. If we continue to apply these powerful psychological insights just to maximize corporate goals time on-site and ad revenue, are we building powerful tools, or are we simply creating better addictions?
Now, consider the alternative. If friction is a necessary feature for security, critical thought, and user autonomy, how would you use the principles we've discussed today, Fitts' law, Hick's law, the Doherty threshold, to deliberately reintroduce targeted, beneficial friction into your next product, thereby protecting the user's focus and agency? That is the essence of ethical, human-centered design.